Now, problem 8 is easier than problem 4. It has some tricky aspects to it though, and I think my general video might help if you watch that before you try to do this. But in any case, problem 8, the first thing we need to do before we can get into the details, we have to define what we mean by the cosecant and the secant, because you see, let's say we have an angle. I'm going to use 30 degrees again, roughly. I mean, this is my approximation of what 30 degrees might be. I don't know, something like that, I guess. Now, I'm going to show you if this is 30, this is 30. It's supposed to be the same. Anyway, the sine, remember, was the opposite over the hypotenuse, which, let's call this with decimals, 0.5 over 1. And this one was, we talked about this in the general video, but that's really the square root of 3 over 2. And the radius is 1, or the hypotenuse is 1. So I'm showing here a picture of the cosine of theta, the cosine of 30 degrees. And I'm showing here the sine of 30 degrees. And the thing about it is, if the sine is, say, you see, the sine is basically the upside down of the cosecant. That is to say, remember, this was opposite over hypotenuse. The cosecant, which you can write it, is the hypotenuse over the opposite. In other words, instead of being this over that, the opposite over the hypotenuse, it's the hypotenuse over the opposite. But you know, another thing that we might want to use when we use numbers, the hypotenuse over the opposite is actually the same thing as 1 over the sine. I mean, 1 over, I mean, that is the same as that. I won't take time to show that completely here. You can figure that out on a separate piece of paper if you want. This, which is the upside down of the sine, you can write it like this, 1 over the sine. In other words, you could say the cosecant is 1 over the sine. That's the point that we often use. If we know the number for the sine, we can put 1 over it and get the cosecant. Now, with my example of 30 degrees, I better put that down here because this is all the general things that don't have the numbers in them. But if we're talking about the cosecant of 30 degrees, going back to that, it's going to be 1 over whatever the sine was. Well, I didn't finish writing what the sine of 30 degrees. You know, I sort of ended up talking in more general terms. The sine of theta is the opposite over the... This is all stuff really about any angle. And even this one, let me write it like this. The cosecant of theta is 1 over the sine of theta. Therefore, the cosecant, I'm just making this a little easier to read, I think. The cosecant of 30 degrees is 1 over the sine of 30 degrees. 1 over the sine of 30 degrees. And we showed up here that the sine of 30 degrees is 0.5 over 1. So the cosecant is 1 over 0.5, which turns out to be 2. Now, a cosine of 30, it's similar to this idea. The cosine in general is the adjacent side length over the hypotenuse. And the secant is the hypotenuse over the adjacent. But we sometimes want to remember that that's the same thing as 1 over the thing that the cosine is, which is this. These are just two ways to say the same thing. But when we have the numbers, it's easier to use this sometimes. Therefore, we want to say this. Let's jump to 30 degrees. The cosine of 30 degrees is 0.866, or square root of 3 over 2. The secant of 30 degrees is 1 over that, which, if I put that in my calculator, we have 0.866. I'll put 1 over that. The inverse equals 1.15. So that's the secant of 30 degrees, and that's the cosecant of 30 degrees. But I needed to give you the idea of what the cosecant and the secant is. But now let's solve the problem number 8. It's just a matter of plugging in these ideas now, because problem 8, they were asking you, they give you a number like this. Secant of theta is 2.72. I don't remember the rest of it, but it's something like this. 2.72 blah, 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 blah. Well, if the calculator would give us secants, we could just use a calculator on this, but we have to convert this. Remember, the secant, we said in the previous part of this video, the definition of it is 1 over the cosine. So really, they're telling us that 1 over the cosine is this number here, 3, 4, 5, 6, 7. So really, let's multiply both sides by the cosine of theta. We have 1 equals 2.72 blah, blah, blah times the cosine of theta. Now, let's divide both sides by this. This is kind of what I've already been talking about in this video. The 1 over this, 1 over the secant, 1 over the cosine is the secant. That enables us to find out this is. So in other words, they were asking us to find theta. we know that theta is an angle that has, I need to do one more calculation. What is this? The inverse of 2.72. Let me put that in here. 2.72 blah, 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 blah. 1 over that is, where's my 1 over? Yeah, the inverse is this. 0.367. Let's put that right here. 0.36718. 0.36718 is the cosine of this angle. So, in other words, theta is going to be an angle. See, they were asking us to find theta. The cosine of it is just 0.36718. If that's 1, that's a picture of it. But still, we don't know what theta is quite yet. We have to use this rather confusing notation, which is called the arc cosine, or sometimes called the inverse cosine. It doesn't mean 1 over. It's confusing that way. It means what's the angle that has a cosine of 0.36718? That's the theta that we're looking for. What is that theta? What is it? It looks like that in my picture. The way we can find it, because the calculator does give us these arc cosines or inverse cosines. You can do it like this. Put the second key down, then cosine. Now, the arc cosine is 0.36718. And the angle, or the theta, is 68 degrees, 0.346, something like that. I just took it out to 2 decimal places. That's the answer to that question. Okay.